So, welcome to the School Science Shed. This is episode 1 in a series of videos which are designed to help you revise for your GCSE Physics if you are studying in England. If you're not in England, then particularly if you're not very clear about what the English education system is, GCSE in England we study from normally from ages 14 to 16. So if you're in that age range and you're studying physics, then hopefully what I'm telling you will be useful. After all, physics is the same the whole world over. However, of course, you'll have to check your curriculum properly because I may not cover everything you know and I may cover some things that you don't know. And even if you are in England, you can't rely on the content of all these videos to tell you what the syllabus is for you. Different exam boards have slightly different syllabuses, so it is possible that I will leave some things out that you need to know, and more than possible that I'll include some things that aren't on your particular syllabus. So the onus is very much on you to check that. And what we're going to look at today is the things that you probably already knew when you started your GCSE course because you learnt them lower down the school, maybe even in primary school. But I think it'll be really useful to go through those things so that you've got something to build on when we do the next episodes. So first of all, one of the really important things that you should have learnt when you were studying before you started your course was that most of the energy we use on Earth can be traced back to the sun. And in subsequent videos I might talk about some things that can't be traced back to the sun, but for now just remember, if there's an energy resource on the Earth, it's more likely than not that the energy in that resource originally came from the sun and we could trace it back to the sun. And let's take a look at what we mean by that. So we'll take an advantage. What we've got here is petrol or diesel that the people who look after you at home might put in the car to get the car to go. So where did that come from? Well, it would have come from crude oil that was taken out of the ground, and then the crude oil itself would have been separated into different useful components, one of which would be petrol. So the energy in the petrol was originally energy in crude oil. Crude oil formed from microscopic living things which lived millions of years ago. And where did they get their energy from? Well, speaking in a physicist way, a biologist would say my use of plants and animals here isn't quite correct. And if you want to know more about that, you can either wait until I do a biology set of videos or talk to your biology teacher. But we've got plants and animals here, microscopic plants and animals which are living in the sea. And then when they died, they sunk to the bottom of the sea, didn't completely decompose and ended up forming the crude oil. And where did they get their energy from? Well, if they were microscopic animals, they would have got their energy by eating microscopic plants. And if they were microscopic plants, they would have got their energy from the sun. So you can see what you're putting in your car here, originally the energy in that came from the sun. Just before we go on to the next slide, you might be thinking, hold on a minute, are these arrows not pointing in the wrong direction? Because we're trying to trace the energy back to the sun. But the energy, these arrows are actually showing which way the energy was moving. So it went from the sun to the microscopic creatures, from the microscopic organisms to crude oil, and then extracted from crude oil to form the petrol. And you'll be familiar with this idea from your biology studies at Key Stage 3, where if you do a food chain, you show the direction in which the energy is transferred up the food chain. Same idea. So how does energy reach us from the sun? Well, it reaches us by electromagnetic radiation. And electromagnetic radiation is electric and magnetic ripples. And there are various types of electromagnetic radiation, X-rays, gamma rays, light rays, infrared rays, radio waves. The sun actually emits all of those. and they move out in all directions, and they travel through space, and they reach us in the Earth. And most of the energy that comes from the sun is transmitted as light, quite a lot as infrared radiation, and then there's other forms of radiation that come from the sun as well. So the sun provides us with the energy, and it reaches by electromagnetic radiation. One of the things that human beings be really interested in is, where do we get our energy from, the energy that powers us and our life processes. And basically that energy comes from our food. And energy in food is stored in the form of chemical energy. And in another unit, another video, we'll talk about what exactly these different forms of energy are. But for now, we'll just leave it that food contains chemical energy. And you also might be thinking, okay, well, if that's the case, can we trace that energy back to the sun? And the answer is yes. So if we look at this delicious Sunday lunch, if we take, for example, the beef, it's probably a bit overdone for me, but, it still looks good. Well, clearly that came from a cow. Where did the cow get its energy from? Well, by eating grass. Where does grass get its energy from? Well, photosynthesis, energy from the sun. And then this piece of broccoli here. Now, I know broccoli's not everybody's cup of tea. I love it, but I know there are lots of people who are not so keen. But where does it get its energy from? Well, it's the same, isn't it? It's photosynthesis. So the energy is traced back to the sun. And we could go on and we could do the same thing with all of the food on the plate. So, parsnips, potatoes, they are obviously plants. They get their energy from photosynthesis. In the Yorkshire pudding, well, that's a mixture of flour, which is a plant, milk from a cow, and an egg. So obviously the chicken and the cow got their energy by eating plants. But whichever way you look at it, you're going to be tracing the energy back to the sun. The other thing you would have learned about was generating electricity. You would have learnt that if we want to generate electricity, we can use fossil fuels like coal, oil and gas. We can use nuclear fuel, which would be a radioactive substance like uranium, or we can use renewable energy. And we'll take a look in detail about what those different types of energy are. So we've got these different types of renewables. I'm not going to go through these in detail because I'm going to cover them in a later video. But obviously we've got all these different things. So solar, we'll be getting energy from the sun. Wind energy, getting energy from moving air. Hydroelectric energy, where you build a dam and you trap some water. Tidal energy, where you use the energy of the tides. Geothermal energy, which is using heat under the earth. And then biomass, which is using energy from living things. So, for example, if you grow trees and then cut them down and burn the wood in order to generate electricity, that's a biomass renewable energy source. So that's how we generate electricity. You will have learnt about thermal energy. Now, thermal energy we might in everyday speech call heat. And one of the things about thermal energy is that it naturally travels from hotter regions to colder regions. So if you look at this photo here, we've got these people who are camping, and they've lit themselves a campfire to keep warm. And the way that's working is the fire itself is very hot, and then the thermal energy transfers from the very hot fire to the quite cold campers, and therefore warms them up. And one of the things you need to know about is how thermal energy is transferred. And it actually transfers in 3 different ways. So the first way is called conduction, and it's when heat transfers by passing through materials. The materials themselves don't move, but the heat passes through them. It's transferred through them. It's conducted through them. And metals are good conductors. They're good conductors of heat. They're good thermal conductors. Non-metals are normally not very good conductors of thermal energy, and we call them insulators. And we can use ideas about thermal conductors and thermal insulators to design useful things. So if we're looking at a saucepan, what we really want is we want the heat from the cooker to get into the food. So we need to make the base of our saucepan from a material which is a good conductor, and for ease, so we don't have to join things together where we don't need to. In this case, the whole saucepan is made out of a metal. It's actually made out of stainless steel, which is an alloy. It's mostly iron, mostly the metal iron, and then it's various other things mixed in with the iron to make stainless steel. It's a good conductor. And then when we pick the saucepan up, what we don't want to do is we don't want to burn ourselves, so we don't want the thermal energy being transferred into our hands. So we need to make the handle out of an insulator, and in this particular case it's made out of plastic. So that's one way in which thermal energy can move. Another way that thermal energy can move is by being transferred by currents in substances. But for currents, the substance has to be able to move. And the substance is only going to move if it's a liquid or a gas. If it's a solid, it can't flow. So convection, this method of heat transfer, only happens in liquids and gases. And we've got an example of it happening here. Here's a beaker of water. It's being heated underneath by, say, a Bunsen burner. The water here is warmed up, so it starts to rise. When it gets to the top of the beaker, it can't rise anymore, so it spreads out. And then it cools slightly, so it starts to fall again. And then what's happening here is more water is moving in to take the place of the water that's risen. So that is how thermal energy is transferred by convection. And then finally, thermal energy can be transferred as electromagnetic radiation. Now, if you've been remembering things, you'll remember that we talked about electromagnetic radiation as the way that energy reaches us from the sun. So basically what happens is that anything that is hot gives out electromagnetic radiation. If it's not too hot, most of that electromagnetic radiation is what's called infrared radiation, but if you make it really hot, it will also give out light as well. And what we've got here is an infrared camera taking a picture of a vehicle. One of the interesting things you can see here is that the tyres are the warmest part of the vehicle, and that's because as they're rolling and rubbing on the road, friction causes them to warm up, and therefore they're hotter than the rest of the vehicle. That's why they're brighter in this picture here. So electromagnetic radiation is given out by any object that's hot, and it spreads out from that object in all directions in straight lines. So that's how thermal energy is transferred. And then the very last thing that you need to remember from your previous studies before you even started GCSE is that energy can be measured, and because it can be measured, we've got a unit for measuring it. And the base unit for measuring energy is joules. But the joule is a really small amount of energy. So it says on this slide sometimes, but actually the truth is often when we're measuring energy, we don't use joules, we use a bigger unit, we use kilojoules. And 1 kilojoule is 1,000 joules. So that takes us to the end of the first revision video for GCSE Physics. I hope you've enjoyed it. I hope you found it useful. If you've been listening to what I've been saying and you're thinking, well, hold on a minute, I'm sure there are lots of things that I need to know for GCSE that he hasn't mentioned at all, you're obviously right, because we've only gone through the very basic stuff that you learn even before you started your GCSE course. And each of the topics that we've spoken about in this video, we're going to come back to and study in more detail. If you have found the video useful, then please give it a like, because that'll make it easier for other people to find it. If you've got any questions, then ask them in the comments, and I'll either answer them in comments, or I might do a video, particularly for really good questions. I might do a video where I answer some of the questions that you've put in the comments. And if you'd like an alert for the next video, then click the bell and you'll get a message when the next video's posted. Until then, what I'm very much looking forward to the next video, goodbye and good luck with your revision.